So today we're going to talk about parametric equations. Okay, so remember when we talked about polar equations, okay, when we have x, y, like we have y equals some function with an x, we call that rectangular, right? Then we talked about polar, okay, with r and theta. Now we're going to talk about parametric, okay? So parametric equations, we're still going to be on the xy plane, but our points are going to be f of t and g of t. What does that mean? Basically, we're going to have an equation for x and an equation for y, and a third variable usually is going to be t. Okay. So instead of having one equation with x and y, we have an equation for x and an equation for y in terms of a third variable t. Okay, like this down here. You're used to seeing this, right? Y equals negative x squared over 72 plus x. But here in parametric, x equals 24 squared root of 2t. Y equals negative 16t squared plus 24 squared root of 2t. Okay, we just have two equations in terms of t. Okay. So instead of like plugging a value in for x to find your y, we're going to plug a value in for t to figure out x, plug a value in for t to figure out y to get our xy coordinates. Okay. Something else that is different about these parametric equations, okay, when you see the value t, what usually comes to mind as far as application? T sometimes stands for time. Okay, now t is not always going to stand for time because t can be negative. Okay, but as we plug values in for t, as we increase our t values, we're going to get some sort of curve. Okay, so as we plug t values in, and as t gets bigger and bigger, we're going to plot those points, and we're actually going to put these little arrows signifying the orientation of our curve. Okay, so in this curve right here, we plug in 0 for t to start here. We plug in 1 for t to get this point. We plug in 2 for t to get this point. And so as we draw the curve, okay, goes this way, so we're going to put arrows saying that as time passes, this is the direction that it goes. Okay, so your graphs will look different because they're going to have arrows telling you their direction. Okay. So there's going to be a couple different ways to graph these. Okay, here is a very straightforward way. Okay. Instead of making an XY table, we're actually going to make a TXY table, and we're going to plug values in for T to get our X and Y. Okay. Then we can plot those points and indicate the orientation, put in those arrows saying what direction our curve is going. Okay. So in this example that you're writing down, you'll notice that we actually put a restraint on t. We only want t from -2 to 3. So we're only going to get a piece of a curve. So what we're going to do here, we're going to make a TXY table. Okay? So where do they want us to begin with t? They want us to begin at -2. So when t is -2, when we plug -2 in for t in the x equation, what do we get? 0. So x is 0. When we plug -2, and for the y equation, we get -1. So we have the coordinate 0, -1. Okay, let's increase our t value. Let's try t is -1. When t is -1, what do we get for x? -3. When we plug -1 in for t, what do we get for y? -1/2. So -3, -1/2. Okay. How about t is 0? What do we get for x? -4. How about y? Everybody, how about y? Thank you. I want to make sure you're actually listening here. T is 1. What do we get for x? -3. What do we get for y? Any ideas on what this is going to look like? Starting to kind of look like a parabola, isn't it? Okay. T is 2. What do we get for x? 0. What do we get for y? A little bit of symmetry here. Okay, and then they want us to go all the way until t is 3. So when t is 3, what do we get for x? 5. And what do we get for y? 3/2. So here we are at 1, 2, 3, 4, 5, 3/2. Okay? So now, we began when t is -2, which is right here, correct? And then we went to t is -1, t is 0, t is 1, 2, and 3. Okay? So the direction of our orientation, okay, the arrows that we need to put in here would go this way. Because as we drew this, our t's increased. Questions? Yes.
Would you just draw it to the last point, or do you continuously go along?
Since they asked for t is between -2 and 3, then we would only graph it between those 2 points. If there was no restriction on t, then we'd have the entire parabola. Okay, we'll look at that in a little bit, okay? Okay, now in this example, we said, hey, t had to be between -2 and 3. Okay, not always will they give us that piece of information. Okay, so let's look at this example. We have x equals the square root of t, and y equals t plus 2. Okay, now, there is no restrictions for t, so we kind of have to figure that out. Sometimes there's not going to be any, sometimes there will be, okay? So we need to look at the domain, all right? So first of all, if I look at the domain for our x equation, what would it be? Okay, t can't be negative, can it? So t has to be greater than or equal to 0. Okay? What about here? T can be anything, right? What? Right? Okay, sorry. T can be anything, right? Okay? So as far as a domain is concerned, all real numbers. Would you like me to do that? Okay.
What did you do before?
The R with the double bar means all real numbers. Okay. Okay, so where these two overlap is the domain. So where do these two overlap? Equal above 0. Okay, so t has to be greater than or equal to 0. So when we go to graph this and we start making our x, y, t chart, where should we begin? We should begin at 0. Okay, so let's do this. When we plug 0 in, what do we get for x? What do we get for y? When we plug in 1, what do we get for x? Radical 1, which is 1. How about for y? 3. Okay. Now we can plug in t is 2. Is it going to give us a nice point? No. So it's okay for us to skip plugging in 2. What would the next nice number be to plug in? Let's just go to t is 4. Okay. And what would our x be? What would our y be? Okay. So then we would have what looks like half of a parabola. Now, do we have an end point for our domain? No. So this is going to keep going. Since we began here at t is 0 and we continue with t is 1, t is 2, 3, 4, our orientation is going to be that way. If you do not have the arrows on your graph, then it is not a parametric graph. Okay? Make sure your arrows are on your graph. Otherwise, you will be docked points on Wednesday. All right? Okay. Now, there could be times where both x and y, t could be any value, and if they don't give you any constraints for t, then you can start plugging in t values until you kind of have a shape. Okay. There's also something else we can do. We can do what's called eliminating the parameter. Okay. Right now our parameter is t. That's why we call it a parametric equation. Okay. So we have two equations in terms of our parameter t, where we're plugging t values in and getting our xy coordinates. Now we are still on the xy plane, correct? Okay, so it is possible for us to take these two equations and get rid of t and squish them together to just get an equation in terms of x and y. Okay, so let's look at how to do that. Okay. So eliminating the parameter means we're getting rid of t and we're going back to just a rectangular form. Okay? So both equations have a t value in it, correct? Okay. So what we can do is we can take one of those equations and solve for t and then plug it into the other equation so that then we have something in terms of just x and y, and then make it look pretty until we know kind of what our graph is supposed to be or what kind of an equation we're working with. Okay. It does not matter which equation you pick to solve for t. However, sometimes there will be an easier one to pick. Let's look at an example. We're gonna look at, I think, 3 examples. Okay. Does this one look familiar?
Mm-hmm.
Yes. Okay. What did we get when we graphed this? What? We got a parabola that opened to the right. So hopefully when we write our equation, we will get that. Right? Okay. So let's pick a t to solve for. What equation would be easier to solve for t? Y would be a lot easier, right? To solve for t in our y equation, what do we have to do? Multiply our 2 over, so t equals 2y. Okay? Now, we're going to take that and plug it into the x equation. So we have x equals 2y, the quantity squared, minus 4. So now, from here, we have one equation with just x and y. T is gone. Now we're going to simplify this so it actually looks like an equation for a parabola that opens to the right. Okay? So I'm going to go ahead and move this 4 over. So we have x plus 4 equals 4y squared. All right. The coefficient, does it go with the squared term or the non-squared term? The non-squared term. So we need to write this as y squared equals x plus 4 divided by 4, which would be the same as a coefficient of 1/4. Okay. This is a parabola that opens to the right because we have a squared y and a positive p-value. Where is our vertex? -4, 0. Okay. And we know it opens to the right. Okay. Our p-value isn't really nice, is it? Okay. So I'm not going to make you graph like a focus of 1/16, okay, to get those other points. So we can, if you were going to use this to graph, you could plug values in. Okay, but we know what this looks like. This looks like a parabola opening to the right, going through these points. Okay, you are not going to put arrows on the end. We have a direction since this is a parametric equation, right? So you have to put arrows that, saying that that's the direction of the parametric equation. Okay. How did I know to put the arrows going that way? We've already graphed it. If we hadn't graphed it, we could plug in 0 and figure out that we're there. Plug in 1, figure out that we're here. From 0 to 1, we're going this way, so we know our arrows need to go in that direction. Yes. We already graphed it, so I knew that that's where they were. All right, let's look at another one, maybe a little bit more complicated one. Do you have a question? I just said a little bit more complicated. I don't know if it's necessarily more difficult. Okay, first of all, let's talk about the domain. Okay, let's talk about the domain of y first. Are there any t values that are not okay? Okay. T cannot be -1. Okay, let's look at x. Are there any values that are not okay here?
Yes. Yes, it is 0, right? Greater, 0 greater.
Well, the square root needs to be bigger than 0. So what t value would correspond to that?
Greater than more than 1.
Okay, t needs to be greater than -1. Can it equal -1 here? No, because the square root of 0 is okay, but not in the denominator. Okay, so where do these two overlap? If I squish these together, what's our domain? T is greater than -1, right? T can't equal -1 here, so this really didn't even matter. Okay. All right, so that's our domain for the parametric equation. Now let's actually eliminate the parameter. Which one of these is it going to be easier to solve for t? Think so?
Without base, let's do that.
I just don't like the square root.
You don't like the square root? Okay. Okay, here's my issue with y. There's two t's there. Do you see that? If it were a 1 on top, it'd be easier. But we might be able
Let's
to.
just do
Ethan Jackson's gonna be easy.
Dude, we can try y. If you guys want to try y, we can try y.
We should try X.
Okay, we gotta get t by itself.
Is this tricky for one?
Do you want to go back to x?
Yes.
Okay.
Now you do.
Okay, so let's go to x. What do you want to do for x? Multiply the denominator over. Okay. I like to divide by x. Let's get the square root by itself first. So we have the square root of t plus 1 equals 1 over x. Now, Jenna, what would you like to do? We can square both sides, which would give us t plus 1 equals 1 squared over x squared, or I'm just going to write 1 over x squared. And then subtract the 1. So we have 1 over x squared minus 1. Wonderful. Now we get to plug this in for y. So we have y equals t over t plus 1. Okay, our algebra skills are going to have to come back. All right. First of all, what do you notice? Okay, our 1's canceled. So we have 1 over x squared minus 1 all over 1 minus x squared. Now what? Okay, so Sarah said, can we go ahead and do the multiplying of the reciprocal here? Would you like to try that? Okay. You guys are in charge here. We have 1 over x squared minus 1. That's our numerator. Let's multiply it by the reciprocal of our denominator. Is this going to be helpful? So we multiply here to get 1. We multiply here to get so y equals negative x squared plus 1. I rearranged it. Okay, So this is back to, this looks like back what we did in like chapter 1, right? The y equals negative x squared plus 1. Okay? Now, if we were to graph this, which we will not, would it be the entire parabola? It would not. Why wouldn't it be the entire parabola? Because we have restrictions on t. So it's not going to be the entire parabola. Okay. Great. Thank you. All right. Questions on this one? Okay, now typically we see t as our parameter. Sometimes we will see a theta as a parameter. Okay? If there are any trig equations involved, then sometimes you will see a theta. So do not panic. It's still a parametric equation if there's a theta. A parametric equation, we know it's a parametric equation if we have x equals something, y equals something in terms of the third variable. I would say 90% of the time you're going to see t. Every once in a while you're going to see a theta. So this is our last example. I saved the best for last. Okay. Can we solve for theta? No. So we need to be a little bit creative here. Okay? We know a couple things about sine and cosine. We have these things called trig identities, right? There is one trig identity that has both cosine and sine. What is that one trig identity? We have sine squared, cosine squared plus sine squared equals 1. Okay, this is one of our trig identities. It's something that relates sine and cosine together. Okay, we picked this one because we have a cosine and a sine. Now, if we go up here and we solve for cosine, cosine of theta would be the same as what?
1/3 x.
Okay, 1/3 x. Sine of theta, if we solved for that here, would be the same as y over 4. So, if I use that, and I use this identity, what is cosine squared? X over 3, the quantity squared, so x squared over 9. What is y squared?
Y squared.
Or what is sine squared? Y squared over 4.
Or 16.
Ah, ooh, thanks. I got excited. What do we have? We have an ellipse. What kind of an ellipse?
Vertical.
Vertical with the center at?
Yeah.
All right. What would our orientation be? Well, which direction do our arrows go? Are they going to go clockwise or counterclockwise? How could we figure that out? Okay, we can plot points. Now, are we going to plug in 0, 1, 2, 3, 4? No, we could plug 0, and then we could plug in like pi over 2 or pi over 4, an angle, right? Theta needs to be angled. So when we plug in 0, what is our x? 3. 3, what's our y? So we begin at this coordinate right here. When we plug in pi over 2, what do we hear? 0, what do we get here? 4, so we would be here. So our orientation is this. Okay?
Does it matter how many arrows put on that?
No, I just need to see that, at least a couple. Okay, give me at least 2 arrows. Okay? Don't go overboard with your arrows. I don't need one every centimeter. Okay? But give me at least a couple. Now, technically, the domain is all real numbers, but it really is only going to take between 0 and 2 pi to draw this ellipse. If we keep plugging in thetas, it's just going to trace that ellipse over and over and over and over and over again. Okay. So technically our domain is all real numbers, but it only takes from 0 to 2 theta to draw one ellipse. Okay, so you have a book assignment. Yay, a book assignment. That means the answers are in the back. If you don't want to take your book home, take pictures of the problems.
I don't know what you're plotting right now, so it doesn't sound good.
Now, I will tell you,